Assalamu alaikum. My name is Mohammed Bat Khan, and today I'm going to explain the lab example on the lab task 1 of our lab 8. In this lab, we use the USART communication method. We learned about it and we performed a few tasks. So I'm going to be explaining the code and then displaying the Proteus. So first of all, here we are defining our CPU frequency to 16 megahertz clock speed that our microcontroller is going to be working on. Then we are just defining and configuring our ports and our pins for our LCD to display our data that we are going to be displaying here. Then we are just including these header files, the area header file, the delay header file, the studio lib header file to just use some of their functions. We are including a library of lcd1.h. I included this by right-clicking on my lab 8 file, then going to add an existing item and adding that library from here, and you can see that it is here. This is our LCD library, and then we are just starting our main function here. We have our port configuration. We are setting the port B and port C to output because we are going to connect our LCD here, and our LCD is enable and our spin as well as our data pins here to display the data. Here we are just setting our LCD in 8-bit mode to display our data on it. Here we have this UBRRO, which is our baud rate register. Here we are going to be setting our baud rate according to the 16 megahertz clock speed. We are using the formula. Here we can see this formula. We are using this formula here to set our baud rate, and according to these formulas we found out that our baud rate is 9600. So we are setting and we found out the value using that formula. Then in this one we have our UCSRORGOB register. What this register is, it is the status and status and control register, and using this register we are enabling our transmitter pin, and using this we will transmit our data to our receiver. This pin will be connected to the receiver pin of the other Arduino Mega that we will be using here. Then we have this again we have this control and status register. uh, Here we are this time sending 8-bit data, one stop and zero parity. We use parity to for our error correction, but here we are not using any parity. Then we are just simply initializing and declaring some variables here. We have declared a variable, or sorry, initialized a variable name count. We are initializing it to the value of 0. Then we have simply declared a character array, we can say. This is going to store our data that we will be converting to string. um, Talking about that, we have our while function, and then this function here is converting our data into string. So the number that it will get here, it will be simply converted to string, and this is our base number that we are using. So it will use the base 10, meaning decimal, and it will convert it into decimal string, which will then be displayed on the LCD. Because the LCD can't just simply display numbers, we have to convert it to string, and then those strings will be displayed on our LCD. Here we are just setting the cursor to row 1 and our column 0. So on the top, first is going to display a transmitter written like this. and then the set cursor will be going to our row 2, and then it will be displaying the value of temp. So here what we are doing is we are simply converting the count, uh, and we are storing that string value into temp, and then we will be displaying that string in here. And then we have our UART data register. We have to wait for the data to be sent. If it is not sent, the code will be stuck in this loop, and it will be stuck in this loop until until this UART data register is empty. So what we are simply doing is we are checking here that if the register is empty or not. If it is not empty, the loop will be stuck here. If it is empty, then it will go out of the loop, and we will simply send the count number to our receiver pin, and we will just increment the count, and it will be incrementing continuously. And then we simply have our 500 millisecond delay here. So let's move on to the code of our receiver. uh, I have already built these codes, and I have already completed my Proteus here, and we will simply just I will simply just show the Proteus here. Uh, here we have defined our pins right here, and then uh, we will simply I'm sorry. Uh, we have simply just defined our CPU cycles here, and we have again declared our pins of the LCD like before. We have defined these pins here, and what these pins are simply going to do, they are going to be set as output, and these will be connected to our microcontroller and simply displaying our output. We have simply again put our header files here, and we have included rlcd1 .h file, and I showed already how this should be included. And then we have our main function here. We have simply uh, declared or configured our pin as outputs for our LCD pins to be connected here. We have simply again uh, configured our LCD as 8-bit here, so we can use it. We again use the same baud rate here, because both of the baud rates should be same for them to communicate. And I already showed the formula which we use to find out this baud rate here. Then we will simply enable our receiver here using the control and status register. And again, using another control and status register, we will simply give it 8-bit data and one stop bit and no parity like before. Because if we set parity here and we do not receive it, it is going to conceive it as an error, and it's not going to read it really. So we don't have any parity here as well. Then we have our variable here. We have declared a variable c here of char data type, and we have again declared uh, one of an array which is of 10 index, and it is simply going to store our data as string in here, so we can display it on the LCD. We have our while data here. So this time, previously we saw that it was waiting for the register to be empty. This time it's going to wait and check that if the receiver 0 pin that I'm going to be showing here shortly is receiving data or not. If it is not receiving any data, it is going to be stuck in this loop. If it is receiving data, it is going to move out of the loop, and then simply we are reading the data, converting it into a string function. I already explained how this works. It simply takes the string number, the decimal number. It uses the base 10 to convert it to string, and then it stores it into the count, and then we simply tell our LCD how to display this data. We move it to row 1, column 0, and we show the word receiver there, and then we move it to row 2 column 0, and then we simply show the count or the string there, and then we also again wait for the 500 millisecond delay. So now here is our Proteus. I already completed. I'm going to explain it shortly. um, First of all, and this was from the development board. I simply just clicked on the uh, Arduino Mega 2500 sorry 2560 here, and opened up this microcontroller here. I simply searched for this LM016L LCD module, and I simply connected these using these pins here, because wires tends to get messy here, and this is simply according to the configuration provided by the data sheet of these LCD modules. And we simply just connected our data pins, our enable and our S pin to the microcontroller according to the code, as I showed that we were configuring these pins on top of the code right here. So this is how we know which pin to connect them to. So again, the same happened on the receiver side. This is the receiver, the first one is our transmitter, and then here we can see that we have our RX 0 and our TX 0 or transmitter 0 pin here. So we will be using this transmitter 0 pin here, and we have connected this transmitter 0 pin to our receiver 0 pin here. So now let's see the output of our code here. So I'm going to run the simulation. We can see that the transmitter has turned on, and it has started to send data here. Now shortly, this receiver, as you can see that this receiver is receiving some data, and it is displaying that data on the other end. So it is just going to increment like I showed before, and it is going to be displaying the data. It is constantly getting the data, so it is showing this receiver 255 here. So this is our lab task example. Now we will move on towards our lab code. Let me just open up the file. All right, the code is ready now. So this is our lab task 1. So here we are simply just uh, the simple our question was that we have to um, connect a button to in our receiver end, sorry, transmitter end, and we have to press that button, and our receiver should simply just turn an LED on. So so now I'm going to explain this code here. First of all, we are again defining our clock speed here, the oscillation speed, the oscillation frequency. It is 16 megahertz. We are simply using the uh, AVR header here. We have our main function. Uh, we are setting our port B as input, and we are enabling the transmitter bit here. Like I explained before, we are again setting 8-bit data, one stop bit, and no parity. We are using the 9600 baud rate here. I already showed the formula for it, how we found out the baud rate. Then we have our while loop here, and in here we are checking if the button is clicked or not. So pin B, and then we are checking if uh, the pin B, the port B0 pin is receiving some data, some input or not. So when the button is pressed, it connects to ground, so the LED turns off, and when it is not connect, the LED is just turned on, so it displays the output there. So it just simply checks for it, and then we wait and see if the data is sent, uh, if our data register is empty or not. If it is not empty, it just waits in this loop, and it does not send any more data. But if it is empty, it just simply loads the data and sends it towards the receiving end. Now let me show the code of the receiver. So this is the code for receiver. We simply just again included just configured our clock speed. We used our header file, our AVR header here. We have our main function. We are declaring or configuring our port C as our output. We are enabling our receiving our receive 0, on which we will be receiving our data from the transmitter on from our transmitter 0 pin, and we are again setting the control and data register to 8-bit data, 1 stop bit and 0 parity. We are again using the same baud rate here. Then we have our while function, our while loop here. Then in here we will first wait and check if our receiver pin is receiving any data from the transmitter or not. If it is receiving data, then it turns the LED on pin 1. If it is not receiving any data, it doesn't turn on any LED. So now let's just uh, see our Proteus here. I'm going to be showing Proteus in a second. I'm opening it currently. So here is the lab task, our Proteus of it. We are seeing here that when the button is open, the LED is on because it is getting power here, and when I close the button, it gets ground, so 0 passes through here, and it is send it towards the receiver, and the receiver just gives it a 0, so the LED is off. So here we can see this. Now I will show the hardware, some pictures, and some videos of it. So here you can see that the LED is on. You can see that when I was clicking this button, the LED was turning off, and when I removed my finger from it, it was just off. So this was our hardware. Uh, these were our lab tasks here, and this is what we completed yesterday. So thanks for watching the video. Allah Hafiz.